Hello class. For today we're going to be going over tangent graphs for the third time. We are going to incorporate period and how that impacts the graph, how we make the increments and those kind of things. Because we have done how we deal with the period and frequency and overall increments as to how we make our x scale, it should not be too difficult as before. First, I want to go over the basics here. For this question, we have f of x equal to tangent of 2x. Now remember, for amplitude, for tangent, we always write none. So because we don't have the maximum and lowest minimum value from the middle line. The next thing that we're going to take a look at is the frequency. The frequency will be the value that's always located here. The new period would be pi divided by b. Now the reason why it's pi instead of 2 pi is because the original parent function's period is pi for tangent always. So if you do that on here, it will be pi over 2. So each increment, you're going to be actually make it pi over 8. That still does not change. For a particular case, for these guys, if you do not want to make it pi over 8, it's fine. If you want to make it actually pi over 4, that also works out as well. Because all you need to remember is that for every half other ones, like every other ones is like zeros or the middle, and every other ones is an asymptote. Phase shift, there is none, and vertical shift, there is none. Okay, so for this type of question, you know that it's tangent, so it's going to go through 0, 0. It's going to go through 0, 0. And now what we want to make sure is that the period is pi over 2. So what that means is, from the left-hand side and the right-hand side, these two that makes up the vertical asymptotes here and here, the length of this has to be pi over 2. And the only way we can make that is if this, we call this pi over 4, and we call this as negative pi over 4. So generally speaking, what's really different about period will be just these two things. Number one, for new period, it's pi divided by b. And number two, for each increment, it really depends on the situation, but it's actually your new period divided by 2. That will make it actually a lot easier for us to graph. Because all we need are asymptotes and center, and then we just have to draw a bunch of waves. Center, asymptote, center, and asymptote. Because the next one will be pi over 2, and the next one here would be 3 pi over 4. And the distance from here to here will also be 2 pi over 4, which is pi over 2. So you draw another wave, you draw another wave, and so forth and so forth. You get the idea. Okay. All right, next question. Now what I'm going to do is I'm going to incorporate both phase shift and the vertical shift. But for these particular cases, I gave it to you in this format specifically for you guys to practice how to factor out the period value, the frequency value. So amplitude, we still write none, because that's never going to change. Frequency, it's going to be 2. The new period would be pi over 2. Now, each increment here would be pi over 4 because I'm going to take this and divide it by 2. The phase shift will not be pi units to the right because we haven't factored out the 2 yet. So if we factor out the 2, what goes in the parentheses? It becomes x minus pi over 2. So your phase shift is actually pi over 2 to the right, not pi. The vertical shift is just 1 unit upwards. Once all those things are established, we're going to write down our increments. So we're going to write this as pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, and 5 pi over 4. Of course, you can write it as, pi over 2, pi, doesn't really matter, but I just like to go in increments so I don't lose track of where I am. So I have the increments ready. And now also what I need to label is the middle line. The middle line will happen at positive 1. So those are where your midpoints are going to be. Another thing is that we're phase shifting pi over 2 units to the right. What that means is your middle line will happen right here at pi over 2. So if that's the midline, then each of those increments here and here, that should be where the asymptotes are, because from pi over 4 to 3 pi over 4, believe it or not, that's actually also pi over 2, which also turns out to be your period. So I'm going to draw an asymptote this way, draw an asymptote this way, and there we go. We have one full wave that's going to happen like this. And then another thing is going to happen at 4 pi over 4, and then we're going to draw it like this. And that's going to be an asymptote. And another one's going to happen right here. Oh, it's going to be like this, and that's going to be the asymptote. And you get the idea. So, generally speaking, what you really need to remember is that the new period will be pi divided by b. And each increment will be new period divided by 2, not divided by 4. Those two will be the most different thing, I would say, like something that you have to keep in mind when you guys are doing tangent graphs. Last question for the video. Now this looks a little bit complicated, but this probably to the extent of how bad it's going to get. You can pause the video and try it on your own first, and then we can check your answers, or you can just go on it right away. For amplitude, we're going to write none. For frequency, we're going to write 1/2. New period, therefore, will be 2 pi. Each increment, therefore, will be pi, because we're just dividing it by 2. Phase shift would be pi over 2 units to the left, to the right. No, I'm sorry, to the left. It's a plus. And the vertical shift would be 3 units down. The reason how I get pi over 2 is because when you take a look at this, it should become 1/2 x plus pi over 4. So when I factor out the 1/2, it should be pi over 2, because once I distribute the 1/2 to pi over 2, I get pi over 4. So these 6 components should be the correct answer for this question. And then now I'm going to draw my grid, because if I don't have my grid here, then I have to draw it on my own. -3, that's where my horizontal line would be, or my middle line is going to be. And now I'm going to plot all my x-axis, the grid. Each increment would be pi, it says. And so I'm gonna label it as so, and then what I'm gonna do is I'm gonna just label the halfway between them, just to indicate where pi over 2's are, because that's what my phase shift is. Okay, so now my phase shift was pi over 2 units to the left, which is right here. That's where my middle line is going to be. Now notice how it's negative tangent. Negative tangent, guys, it looks like this, the waves. And now, drawing the waves is no problem. I know I need the framework, right? So each increment would be pi. So what I'm going to do here is that if this is where you have started, and my entire increment has to be pi, my two vertical asymptotes will have to happen here, and will have to happen here, because I'm sorry, that's not true. I looked at each increment, not the entire period. If the entire period is 2 pi, that means I need to go all the way here at -3 pi over 2, and then I have to go down here, which is pi over 2, which makes this increment to be 2 pi. And the easiest way, I guess, to check that is every half increment that we did, so 1, 2 this way, 1, 2 that way, that would make it pi over 2, that would make it pi units to the right, pi units to the left, which is still your increment. And so by combining those two, you get your new period, and then those two you will make your asymptotes. And so once I'm done, I'm going to draw a wave starting from the top, going down like this. And then the next one would be happening every 2 increments here. And then the next 2 increments would be here. So 2, 2, 2, 2. And then you would just keep on doing this cycle, and then repeat the waves over and over again. Okay, so hope this video helped. I'll give you 2 questions to do, just like the last one. I'll give you one with negative tangent and positive tangents, incorporating all these different components. Tomorrow we'll do a quick review, and then we'll take a short quiz of tangents on either Wednesday or Thursday. Thank you. Have a good day.